You're welcome to today's episode. So let's move on. Let me quickly share my screen.
Stop doing it, okay? So I know it from the first still. Why didn't I do it?
Limit yourself. Okay, we'll be talking about the surface integral. So we have surface integral for scalar field. For scalar field. So it is, we have two types. We have scalar field and we have for the vector field. So for scalar field, like I explained the other time, for scalar field, there are key things we need to take notes of the scalar field. And that now lead us to different aspects of solving these particular problems. But I don't want you to see it as a big stuff, but they are very simple. But we only need to master the method and the way of solving them. Just pick any of your own. I hope you can hear me now. Can we all hear me? Okay.
Yes, sir.
Yeah, we have integral of this, f of x, y, and z, the x, which is partial derivative, which is same thing as defined on the region. That's why we change it to region f of x, y, z. Then we have to multiply by the field of r subscript u and also the factor of v, the u, the v. So, but this factor of u, v is also in shape of, that is partial derivative of s with respect to u, v. Then you differentiate the y also. You differentiate z also. So in this case now, there are certain things we need to know. Like I explained to us yesterday or the last day. Let's look at this. In this case, certain things need to check. For example, how do we come across this? Let me just try to explain it. That okay, you have from this point, let's say we have u, v in this place. So u, v, there are certain things that can occur at this point. Let's say there is a point whereby then we now said, okay, this is u, the factor u, we are differentiating with respect to u, the u here. So it simply means that let there be another extension to u in this case. That means we have u plus the u, v. Remember, we are coming from this particular point of the two of them. So I now have another extension here. If I have this extension, I now call it u plus the u, u plus du, comma v. But if the same thing happened to this one with respect to vector of v dot dv. So in this case now, we have another extension which is u. This one is a u, comma v plus dv. So which means that the two extensions can meet at a particular point. Call this point here. I can call this point at the point u plus dvu, comma v plus dv. So what am I trying to say is, I'm looking at this particular thing in a parallelogram way. Now, if I'm looking at this one in a parallel, what's the area of the parallelogram? Remember from here, the area of parallelogram is our area of parallelogram in this case is this. Says this place is theta. Then we have this place to be small b and this place small a. Our area will be AB sine theta from our knowledge. Now, but if you look at this, what is the A, what is B in this, our own A, in our own A will be, we have it to be R, RU, that is the vector RU du, absolute value of the same thing, RV dV sine theta. So you can see how these will come across this. And the same thing happened here. If you go further, you discover that, if you go further, we discover that our dx that we have here, partial derivative of the x from the formula here, look at this dx here of the surface, we have it to be the x will be the magnitude of u, vector u, cross vector v, rv, du, dv. So if you have this one, our formula, we can easily write our formula based on what I just displayed up, that says that all we need to do is, how do we get the cross of uv and the cross of v du? So in this case now, we are now looking at integral of x. I'm just trying to lay the foundation of x, comma, y, comma, z, dx to be equals to, now I know my everything. Now I can now say in the region, this particular region now, from the surface to the region, x, comma, y, comma, z, the absolute value, what is the x? I can pick all the x, put it here, cross RV du dv. So now that we have this, we can now know how do we parameterize this particular function. If you are given an example, how do we solve it? Now let's look at the example on full rotational, and let's see how we solve it and how we get into the old formula. So it is very simple. If you are there, let's go. Evaluate. Let me give us this example. Evaluate evaluate integral x, xz plus y squared, the x, you can use this, you can use any, where your s is the surface. Describe by x squared plus y squared equals to 16, 0 less or equals to z, less or equals to 3. So how do we solve this one? Who can tell us the nature of this? You first of all need to, don't just jump into integration. Rather, look for your parameterization to get all your limits. How do we solve this? The solution. In this case, we are given the scale and we are working on the scalar field. So we have this. You and I agree with, you can agree with me that this is what? Who can tell us the meaning of this? This is circle. Do you agree with that? Hello? I need a response. The circle equation, you remember x squared plus y squared equals to r squared. And in this case, you have x squared plus y squared equals to 4 squared. Is already circle equation, right?
Yes, sir.
Now we have a circle, so then in xy plane, so I can get this one ready. This is what? This is our y, and this is our x. Here is the radius, and the radius here is 4 because of this r. Remember, the radius is 4. But now, that's not the way. That's not the final thing. In this case now, we need to take it into polar way. If you take it to into polar form, we need to write this one in polar form. You remember that in polar form, our x is equals to r cos theta, y is equals to r sin theta, and z is equals, in this case now, we only need x, y, z. X, y, z, we are working on, the function is x, y, z, but we are working on x, y plane. But the z is there, so z in this case will represent z alone. Now, which is the same thing as which is the same thing as x, which is the same thing as, I can write this one to be, this one will be 4 cos theta, and this will be 4 sin theta, and this will still be z. So take note of that function. Now that we have this, there are things we need to take note. Now we have everything in theta. So we need to write, remember we are given z, we need our, we are given z to be what? Our z is to be, the limit in this case will be 0 less or equals to theta, less or equals to 2 pi, because we are talking about one full revolution. One full revolution. And the next thing is for the z, let me just put this way so that you know the difference. The z is 0 less or equals to z, less or equals to 3, is already given from the onset. Now, how do we now work on this. Remember, you need R vector R. Our R is U comma V. Then everything. Remember, U comma V is what? In this case to be X of U comma V, Y of U comma V, and Z of U comma V. But in this case, we already have it to be theta and Z. So which implies that R into theta comma Z. Our theta comma Z will be what? You already have it up there. 4 cos theta and 4 sine theta and Z, because we are working in X, Y plane. Now that we have this, the next thing is to differentiate partially. You differentiate partially by saying that I'm still working on the R theta now. If you say R theta means, what is the R theta means now? That is, differentiate each of them with respect to theta. So we differentiate with respect to theta, and we also differentiate with respect to Z. So we differentiate with respect to theta, what do we have here? When you differentiate this with respect to theta, you have minus 4 sine theta, and this is 4 cos theta. This will be 0. Then we go ahead with RZ. So we do the RZ. What do we have? We do the RZ. The first one here will be 0. The second one will be 0 because there is no Z. The last one will be 1 because there is Z. So is that the next? Is that the all? No. So we proceed. Remember, from the formula you have, R theta cross RZ. So we have to do the cross product now. So the cross product, we have I. The first one, which is I component, is what? Minus 4 sine theta. We do the one of J, 4 cos theta. We do the one of K, 0. The next one is, you do the one of 0, 0, 1. I hope we have got this one. So the next thing is to resolve this problem. But remember, we are still doing, let me just remove this so that you will understand that we've not done we are still doing what is inside first before we now do the magnitude. So if you want to solve this one, the way I explained to you the last time, you remember, let's do the I. Factor I will be, when you pick this one, what happened to this? Everything here paralyzed. This row not also paralyzed. It remains 4 cos theta, 0, 0, 1. Minus, because you are doing J, you release this one, you pick this, the row paralyzed, the column also paralyzed. So you have what? Minus 4 sine theta, 0, 0, 1. Yes, Oyedele. You raise up your hands.
Sir, please, can you just help me with yours? Yes, sir. It's because I was, my connection was bad, so I was locked out. I couldn't get what we were talking about right from up the screen before the vector theta and z. So I was lost in between, sir.
Okay. What will happen is this. I will explain on one okay, let me just go because of others too. That is on the same thing. Although you will still see everything in the video, but let me still quickly do that. Okay, let's start from here. You are here when we did the polar. Were you there?
Yes, I got to when we are having vector of theta and.
Okay, let's continue from there. So we have the R.
That's where.
We have R.
Okay.
Here we have this. We have R, factor R to be theta, comma, Z. So, and we know that this is 4 cos theta, this is our X, this is our Y, this is our Z. Now, the next thing is to use partial derivative. Partial derivative. When you use partial derivative, what happens? Differentiate this with respect to theta. That's the meaning of this. It simply means the R, the theta. That's the meaning of what we did here. And this place is the R, the Z. That is what we did here. So when you differentiate this with the R, the theta, what does it mean? We differentiate this, keep your constants, which is normal figure, which is a constant, and differentiate the cos theta with respect to R. But we differentiate the X with respect to this. So what do you have here? You have this. When you differentiate the X also, and the Y also, no, okay, probably I should put it this way. Differentiate X with respect to theta. We differentiate also this one with respect to theta, and with respect to differentiate Y with also with respect to Z. Then Z. The same thing, the Z. We've done the Z too. So each of them, I think I'm right. Don't let me disturb it because we are doing everything together. We are using the entire R, please. Take note of that. That's why we said R subscript theta and R subscript Z. So it simply means the entire things, you are differentiating them with respect to theta and with respect to Z. So you have this. Then all you need to do is just to do the cross products. That's why you see this is not multiplication, it's cross product. So cross product means using the determinant theorem. When you use determinant theorem, you have this. Everything we have here, arrange them accordingly. Let the X be X and let the Y be Y. This is your I, J, K. This is also I, J, K. So arrange them accordingly. When you arrange them accordingly, you have this. Then we are now trying to pick. We first of all solve this one. And remember the theorem. The entire row will be cancelled. The entire column will also be cancelled. It will remain this, and this. That's why we put it here. But don't forget, this is positive, negative, positive. So when you release this column, release the I, you pick the J, the entire column also will, the second column will paralyze. You pick this and this, 0 and 1, you have this. Then you release this one, you release the J, you pick K2. The one of K, everything that belongs to K will be paralyzed. You now remain what? Plus K. What do you have when you cancel this? You have negative 4 sine theta, 0, 4 cos theta, sorry. So 4 cos theta is 0. Remember, when you cross multiply here, this will be 0. This will also be 0. So you don't even need the last column in this case. Now, we're left with this. So we can continue from here by solving this one, by saying, okay, what do we have here? This will multiply this will multiply this. So when they multiply themselves, what do we have? At the end of the day, we have 4 cos theta here. The minus is 0. Then all these ij, everything will cancel. This one will be, don't forget you have negative here. You have minus 4 sine theta minus 0 and plus 0. So you don't need anything there. So when you open this bracket, this will be positive. At the end of the day, you are left with, going back to this way, you are left with 4 cos theta and 4 sine theta and 0. So that is the answer for this product. Now, the next thing we need to solve now is going to be, we find the cross. The cross of this will be what? You want to find the absolute value of it, the magnitude. We need to calculate the magnitude. The magnitude will be square root of x squared plus y squared plus z squared, the way we normally do it before. But in this case, we have it to be 4 squared cos theta, cos squared theta, plus 4 squared sine squared theta. Remember, we don't have the z in this case. So at the end of the day, you have the square root of 4 squared is common. Cos squared theta is here, plus sine squared theta. You did the trigonometry, I believe so. So if you've done that course before, you should know better that this one will be 4. 4 square will be 4 square, square root of 4 square is what? Then you recall that cos square theta plus sine square theta is equals to what? Is equals to 1. You remember? Then at the end of the day, we have it to be 4. The cross products we are working on is equals to 4. Yes, Teslim.
The component Ij, how did we eliminate them?
Remember that when you do the cross products, go and check the cross product. What happened to the cross product when you open it? And when you find the magnitude, that was the first thing we did in this class. You still remember?
So I'm talking about where we got our 4 cos theta plus 4 sine theta.
Yes.
How did we eliminate the components I and j, sir?
And that is what I'm saying. We are saying the same thing. When you do the I and j there, remember you have I dot j dot k and some other things. Remember that at the end of the day, by the time I substitute it into, I decided not to show that aspect because by the time I substitute it into the magnitude, everything will disappear. Do you agree with me? Do you agree on that note?
Yes, sir.
Oh, okay. So that was what
Go again.
happened. Any other question? You can only get those things when you substitute it into the what we call it now, into the magnitude, because IJK will still be there after the whole scenario. But by the time you substitute it into the magnitude, remember, by the time you take the square of each of the components, it will give you 1. I hope I'm clear. That was why I just assume you know that one, which means I may not need to disturb myself on top of that. Okay, let's quickly, we've not solved the problem. So in this case now, we now have our R, the modulus, the magnitude value of R theta and RZ to be equals to square root of 4 square, which is equals to 4. So now you can now go to your, yes, Taslim?
No, I'm okay, sir.
Okay. When I saw your hand again. So we have this one, integral of 0 to 2 pi. We go back to our original question, 03. So when we get there, what do we have? Who can remind us now? Anybody? So we have it to be, substitute your polar inside. Let's go, the main question says what? X. The main question says xz plus y squared, right? And the x. So now let's substitute into it. When you are trying to substitute, we have 4 cos theta z plus 4 sine theta all squared. Remember, R is there. We have our R, the Z, the theta. So when you solve this, if you solve this one very well, you have integral of 0 to 2 pi. Now, I will solve this one with respect to Z first. If I integrate this one with respect to Z, I'm going to have 24 into 8 sine square theta plus 3 cos theta, the theta. I know you asked a question that, oh, where do you get all this? It is very simple. Remember, in this case, why do I choose? Because I know that the only thing that can save my head here is just to, first of all, substitute 0 and 3. So by the time you integrate using your trig, if you don't remember this, please go and visit your trigonometry book just to remind yourself and to be able to solve this particular trigonometry. And you will, from the knowledge of that trigonometry, you will discover that by the time I integrate this with respect to Z, I will have something similar into this aspect. Then so the last one you need to do now is, by the time you now integrate this one with respect to pi, what do I have? With respect to theta, rather, what do I have? I will have, and you substitute, you will have 1925 at the end of the day. You know, when you integrate cos theta, you know what it means. When you integrate sine square theta, you know what it is. Check your integration skill, integration manual, you will have all these things explained there. But now, I have another example, but that one will be very short. Why is it that I will use another method of solving the same problem in a different way? So at the end of the day, you will understand knitting and gripping of what I'm trying to pass across to you. But now let's look at this example. Can you hear me, please?
Yes,
Hello?
sir.
Okay. Now let's look at this example. Evaluate.
I.
Go ahead. Surface integral so our x such that our z is equals to 2. Then we have x plus y squared less or equals to 1. Are we there?
Yes, sir.
Okay. Less or equals to 1. Now, so how do we solve this problem? Let's look at this formula first. I will write all the formula in one piece. Look at this. The formula says integral of surface is f of x, y, z. You will be the one to choose the one you like. It's the same thing as integral of region f of x, y, g of x, y. Multiply by, this is multiplied by square root of one plus g subscript x, that is partial derivative of x, y, all squared, plus partial derivative of y, x, y, everything all squared, dA. dA.
So it's not clear.
But you can hear my voice.
Yeah,
If you can hear
voice.
my voice, just use my voice to write. Or probably your network. So the last aspect that I just put is this. Square root of, look at it, 1 plus g subscript f of x, y, all squared, plus gy of x, y, dA. I will explain everything to us, one after the other. Now, can we all see this one, please?
Yes, sir.
Now, when we said g of x, z, the same z is the same thing as g of x, y. Just picture it as Z we have been talking about. Now, in this case now, I have what we need to do is to get the limits for each of our X and our Y. So which means, don't forget we have X squared plus Y squared. Let's say less or equals to 1. When I differentiate the Z, the X is equals to 0. And when you set the Z, the Y is equals to 0. Who is that? So is equals to 0. But that's not the aim. The aim is, we know, you and I know that this is circle equation. Do the same thing we did the other time. This is Y. And this is X. Now, what is our radius in this case? Where you have X squared plus Y squared equals to 1. What is the radius, please?
1.
1. Thank you. So if my radius is 1, here is 1, it simply means that I have 1 here. It simply means that I can rewrite this one by saying Y squared is equals to 1 minus X squared. Then my Y is equals to square root of what? 1 minus X squared. Plus or minus, don't forget. Plus or minus 1 minus X squared. So in this case now, we all know that this is positive Y, this is negative Y. So I can write this one to be Y equals to square root of 1 minus X squared. And here will be Y equals to minus 1 minus X squared. So that is not the where we are going. Now, what this place is telling us is our limit that we are working on can be in this form. But don't forget that when we differentiate this inside this, what do we have? We have 0. This one simply means, let me just use this, G subscript X. G subscript X of X comma Y equals to 0. Then the second one simply means G subscript Y of X comma Y equals to 0. So you can go ahead and substitute it into your formula. What do you have here? Everything here will be 0. This one will also be 0. This will be 0. This will be 0. Then what is the remaining? Everything that remains in this case, we can now substitute. Look at it. I will now write the same formula again. Although at times, if you integrate, if you differentiate it, you can have value. When you have value, you substitute the same value there. But now that we don't have value, we are left with integral of X minus 2Y plus Z,
2y plus Z.
This X equals to, don't forget this is X, integral of r, this is r, you have x minus 2y plus z multiplied by square root of 1. Because it's only square root of 1 that remains. Or square root of 1 dA. You can say square root of 1 dA. Now, we proceed. How do we now write this in a proper way? You can say plus the A, if I said the A, because 0 plus 0 has gone. But at the end of the day, you have it to be, let's substitute our limits. Our limit will now be integral of, the first thing is, remember we have our y. The first thing we need to do now is from -1 to 1. And while the second one will be minus square root of 1 minus x squared, and to the positive of 1 minus s squared. Don't be scared about all this. They are just value. They are just things you substitute at the end of the day. X minus 2y plus 2. The y, the x. Remember, our y is this. Remember, the x is this. How do we get the x? When we substitute the value the other time, we know, you and I know that from this diagram, from the circle, we have it to be 1. That is 1 here and -1 the other side. So, and we can also get this y. We get it because our radius is 1. That's why you can see this one. Please take note of that. If your radius is 4, minus 4 to 4, that's what will happen to them. So let's move on. But for us to make life simple for ourselves, we now move into polar. We do it in the using polar form, the way I did it the other time. We are still going there now. So for us to use polar, using polar, we have x to be equals to r cos theta and y to be equals to r sin theta. But don't forget, you have 0 less or equals to r less or equals to 1, and we have 0 less or equals to theta less or equals to 2 pi. Then I can now go ahead and substitute this into my here. So if I want to do that, to convert everything back to it, I'll take it step one after the other. The first one will be 0 to 2 pi, while the second one will be from 0 to 1. Then I can now substitute my r. So my x will be r cos theta minus 2 r sin theta plus 2. So in this case now, we always have the r. Don't forget r we have the other time, r, the theta. So how do we get the r? Remember when I explained to you the other time we have 4, talking about the absolute value, this place, sorry. So talking about where we have 4 the other time, here, where we have 4 the other time, that multiply the cross products that we did the other time. So it's more or less, it's the same thing as what we are doing now. So always remember when you are doing it, when you get to this point. So we have R, the theta. Now that we have the R, the theta, we can now proceed and solve the problem. So in this case now, we have it to be, let's multiply everything with R first. 0, 2 pi, 0, 1. So we have R squared cos theta minus two R squared sine theta plus 2R the theta. So let's solve the R first. What do we have? When you solve R first, you have 0 to 2 pi. Let's integrate R. So you have what? R3 raised to power 3 cos theta minus 2R cubed over 3 sine theta plus 2R squared over 2, 0 to 1. So I know this one will cancel this, and that's the only thing that cancel. Then I can now substitute 1, upper limit minus lower limit. Substitute 1 first. When you substitute 1 first, what do you have? You will have 1 all over 3 cos theta minus 2 over 3 sine theta plus 1. Everything multiplied by the theta, the theta. Now, we need to now integrate again into, when you integrate the second time, what do you have? For us to integrate this one, so that it will give us, we want to integrate for theta now. So we're going to have, when you integrate cos theta, what do you have? You have 1 all over 3 sine theta. When you integrate sine, you have minus cos plus 2 over 3 cos theta. When you integrate 1, you have theta. Remember, 0 to 2 pi. Upper limit minus lower limit. Upper limit is 2 pi. So let's check it. You have sine 2 pi plus 2 over 3 cos 2 pi plus 2 pi minus, open the bracket, 0 now. 1 all over 3 sine 0 plus 2 over 3 cos 0 then plus 0. Now, in this case, what is pi? What is sine 2 pi? Anybody? Sine 2 pi is what, please?
Sine 360 degrees, sir.
Is what? Sine 360 is
The
what?
value?
Yes. Nobody.
0, sir.
0. 0 multiplied by
sir.
1 over 3,
Yes,
0. Plus,
0.
now, cos 360 is what? Cos 360, please.
1.
1. 2 over 3 multiplied by 1. 2 over 3. Plus 2 pi. Minus, everything sine 0 is 0. Right? Cos 0 is 1. 1 multiplied by 2 over 3 minus 2 over 3. So at the end of the day, we have 2 pi. So this will go with this. So that is how we solve this problem. So all you need to do, you can pick any of the method, they are safe. It is easier for you to solve them. I use the first one to explain the way it is. And why I use the second one, also to give you a kind of shortcut, whereby it depends on how versatile or smart you can be when it comes to exam tension. So the ball is in your court. You can choose to play it up or play it down. It depends on you. Any question on this? Any question, please?
Sir,
Yes, ma'am.
from the question you said, evaluate the surface integral. Now, my question is, because you went through some parts, I don't know, maybe that's the beginning of the solving, or you just use that as introduction for us to get what we're trying to solve.
Which area? Let me see the area of the parts you're talking about.
From the beginning, the question says, number 2 question, it says evaluate the surface integral. Maybe you have the integral.
Yes, we have the question. Go ahead.
Yes, that's the question. Such that z equals 2 and 2 squared
It's not
plus y
such,
squared.
please. That's not the such. It's x, that's the solving. Such that x such that z equals to this. That we are talking about limit at that point. And we now said x squared plus y squared less or equals to 1. Please go ahead.
So now the solution, we have all this. The integral x f into bracket x y z, the x integral the region f. So is that where we're going to start from?
Yes.
If I say if you have to solve it. Hey. Okay, sir.
Is that the question? Or you just want to
That's it.
You want to be sure?
No, that's the question. I want to be sure. Maybe that's where I'm going to start from.
That's
because actually, after you wrote all that you explained, remember you have your dz dx equals 0 and dz dy also equals 0 before you bring about ggs. Remember you said the gs is the same thing as our y, about our z rather. So that's the reason why I said I want to know. Maybe that's the beginning of the solving, sir.
Yes, you are right.
Okay, sir.
That's why they put it hand on paper, so that you can't just go to the computer and be picking. Baba, don't call yourself a lotto. This is not a lotto exam. This is a real exam. You know the type of question you want to solve. It's not that serious. It's the same thing you've learned. That is why to create the time for you guys to explain things to you out of my own schedule, so that you guys will have a better understanding before you get to exam hall. Especially
and also, sir, I have a okay.
Go ahead.
Sir, concerning yesterday class, we stopped at somewhere that he said you should go and complete whereby we do the differentiation. I couldn't get it right. So I sent to one of my classmates to help me in the solving. He has not responded. So I don't know if you can just brush it off.
Don't bother about brushing. I don't even have brush here. Talk less of to brush it off. I don't have
maybe
brush.
Maybe you can just claim me, sir.
We still remember, we've not even talked about Stokes theorem, Green's theorem. We still have them, and you can't escape those questions. Anyway, that's not the issue. God will give it to you. you will know.
And also, there's another pending question that you didn't continue yesterday. I said again to get back to it.
Which one?
That one that is under surface angle.
And that is
I mean,
why
surface
I came
integral.
up with the surface integral now. That's why I'm using this. I said yesterday, that was why I said it yesterday. I said, okay, let me stop the surface here. Let's go to volume. Volume is a bit simple.
Volume
That's
integral.
why I explained. That's why today class is focusing on surface integral, please. So that is the part 1 of surface. The part 2 of surface is when you have the surface and in a vector field. Remember, we did the one in scalar field, but if it is vector field, how do we solve the surface? If it is vector field, how do we solve the survey? Are we there now? Can we proceed, please, guys?
Yes, sir.
Okay, let's look at the one I just mentioned now for the vector field. For the vector field, you have another formula of solving it. And those formulas they are also interesting. Two things normally happen. If you are in a vector field, you have this, let's say you're solving hemisphere. So in this case now, you have what we call the normal, which is n field, n vector. And at this point that we are dealing with, we have the positive and we have also the inward. The inward aspect of it is at the negative side. So what does this implicate? So it simply means we have 1, 0, 0, and the formula to use to solve this also is very simple with what we've learned so far. So I believe you should be able to grab this one quickly than the first one. So it says that integral of surface f vector v and the x. And the x, you can use f the x or partial derivative. Let me just put the partial derivative. And the x. So if you have it in n dx, the entire n dx, what does that mean? So they are talking about a surface f dx, where you have your n dots the s to be equals to vector u, then v sine theta vector n dot du dv. Remember, everything is still coming down from the u, comma v. From u, comma v. Everything is coming from there. So what does it mean is from here to here, we are still talking about So from here to here, we are still talking about R UV plus RV du dv. Now, in this category, like I explained to you about the RUV, there are certain things we need to know. So at the end of the day, we have our region integral. The region integral will be in this shape. So we have it to be in this shape. Which implies integral of R vector V F to be R U comma V dot R U cross R V du dv. So don't forget, I've taught us how to solve this one. Although there are many short ways of solving it, because I'm explaining, I have to be explanatory. I have to be detailed. That is why you see me trying to explain it again and again and again. Or do you want me to use okay, let's continue this way, so that you would, I don't want you to miss it, that, oh, we don't understand what you're doing. I don't want that. But let's look at the example of this. That example 1 on this, it says evaluate. So when you see this, dot the x, where f vector f is the same thing as z over x s squared exponential x squared plus z squared. I think you are talking about this question. And S is the solvent.
Yes, sir.
Okay. As S is the solvent described by x squared plus y squared equals to 16 for 0 less or equals to z less or equals to 3. With the x oriented outward. Don't forget the explanation that I explained. Oriented outward. Always remember this. Check this one. Which one is outward? Which one is inward? We have the one of outward here. We have the one of inward here. So take note of that. But that's not where we're going. So now that we know this, for the outward, talking about cylinder here, at this point we have, this is outward. Now that we have outward, what is going to be our representation? The way we will start this one. From here, we know the solution will be if I said r factor r of theta comma z is the same thing as do we agree with me? If I said 4 cos theta, 4 sin theta, and z, do you agree? Hello?
Yes,
Silence.
sir.
Silence means we agree. Yes. Okay. Now, for r of 0, comma 0, what do we have? R of 0, comma 0 is what? When you substitute theta to be 0 here, what do you have? You have cos 0. Cos 0 is 1. Cos 1, cos 0 is 1. 1 multiplied by 4, we have 4. The others will be 0, 0. Do you agree? That is the same thing as our n factor. Our factor n is the same thing as 4, 0, 0. Our normal units. That's why they call it n means normal unit. That's 4, 0, 0. Now, you agree at this point that r theta cross r z is the same thing as 4 cos theta, 4 sin theta, and this one will be 0. When you find the cross product of these two, this is what you will get based on the knowledge of the first example we did. Then we can now go ahead and do what we call the dot. But before you do the dot, we need to go and substitute into our f. Our f becomes remember your f here, your z over 4 cos theta, because remember your f is the same thing as z over x, then x squared, then exponential of x squared plus z squared. So it becomes this. Then what is our y? You have the second component to be what? 4 cos theta all squared and the last component will be what? Exponential 4 cos theta all squared plus z squared. That is that is what we have as our f dot, because we need to now use dot. Remember, you need f dot from the formula. That's what I'm writing. So we are multiplying this. Don't forget. So when you multiply it, what do you have? So we are going to have dots 4 cos theta, 4 sine theta, then 0. So all these exponential of a thing, everything returns to 0 at the end of the day. So by the time you find the dot of these products, the two of them, you will have it to be component by component. Don't forget, z over 4 cos theta dot 4 cos theta. What do you have? This cancel this. You have z. Then 4 cos theta all squared dot 4 sine theta. What do you have? You have it to be 16 multiplied by 4 is what? Anybody?
24.
64? Okay, you have 64. Just find it out. 64 cos square theta sine theta. And the last one will be 0. So, which implies that you have z plus 64 cos square theta sine theta. So, we need to put it in integral now. Go back to your integral formula. So, our integral formula becomes what? Integral 0 to 2 pi, integral 0 to 3, everything z plus 64 cos square theta sine theta, dz, d theta. When you do the one of the z, you have 0 to 2 pi, you have 9 over 2 plus 192 cos square theta sine theta, everything d theta. By the time you integrate this one, you have 9 pi. Any question? Any question, please? Olabisi, any question?
Sir, please, I need a clarification in the last step, sir.
Go ahead. Which side?
For that, I didn't quite get how you arrive at 9 over 2 plus 192.
You can only get it when by the time you solve it. Okay, it's very simple. You can even see it here. When you integrate z, what do you have? You have z squared over 2. Then when you put 3 here, you have 9 over 2. That's what you are seeing here. Do you agree with me? Hello?
When you integrate z, you have z squared over 2. Yes, sir.
So substitute 3 there, because you are substituting upper limit minus lower limit.
That's true.
Thank you. So then when you integrate this one, what do you have here? You have Z. Because there is no theta here, you only have Z, right? Remember, you are not differentiating.
Yes, sir.
So since we are not differentiating, what do we have at the end of the day? What do you have at the end of the day, please? Somebody should tell us what we have. Nobody? It's not a rocket science, just a very simple analysis you do. Then you get it right. So by that time, you remember everything will just be integration with Z. And substitute 3 into the Z. What do you have? 64 multiplied by 3. You have 192. That's all. So the next thing is just to integrate with respect to theta. You know, when you integrate the second one with respect to theta, 9/2, we have 9/2 theta plus, then integrate this one. So by the time you integrate it, you have this. Substitute your 2 pi, you have this one. Okay, guys, any question? Some of you are coming today when we have special classes. I don't know why.